Differentiation review word problem number 9. It's a little harder than it looks. It says that a car is traveling along a highway shaped like a parabola. Okay, here's a parabola. Let's make it a wider parabola like that. It says that the car starts at a point 100 meters west and 100 meters north of the origin. The origin we're going to put right there, like that. And that means that the car is about here. We'll say it's at negative 1, 1, because I'm just going to say that 1x is equal to 100 meters. Everything's written in hundreds in here, so we're going to do that. It's traveling in an easterly direction. That's that way, to the right, for our purposes. And that there is a statue located 100 meters east and 50 meters north of the origin. We'll put that right about here. I'll label that as 1 and 1/2. There, like that. At what point on the highway will the car's headlights illuminate the statue? So what they're saying is there's some point, let's say it's here, where there's a tangent line, just so, that points right at the intended point. You can imagine there are a ton of uses of this in real life. Being able to track and locate things on the move is super important. So it says, if we need to find out what that point is. So let's call that point XY. That'll be our mystery point. And because I made this point system this way, I can just say that this is from the parabola y equals x squared. It's negative 1 squared is 1. That's the only point on the parabola we know. There's no reason I can't do that. And if we want to go from there, well, the tangent line is going to require we know the derivative. So let's just make sure we write down that y prime is equal to 2x. I'm sure you know the exponent rule by now. And now how do we find this tangent line? Well, slope is defined a lot of ways, but one way is y2 minus y1 over x2 minus x1. I'd sure like to try that. Because we have some of that, we can say 1/2 minus y over 1 minus x is going to be true for this line. And we know that it's going to be equal to 2x because that's true no matter what. So if I take this, let's multiply things up here. So I'll come off to the left side. We'll get 1/2 minus y equals 2x times 1 minus x. From there, we're going to distribute I think that's clear. And I want to move all of this over because something that's fun is to remember that y equals x squared. So I can replace this with an x squared. I like that. So far we have 1/2 minus x squared minus 2x plus 2x squared equals 0. So let's combine our like terms, 2x squared and minus x squared. So I'm going to get x squared minus 2x plus 1/2 equals 0. There aren't a lot of things that multiply to make 1/2, but add up to be negative 2. So I think we're going to have to do the quadratic formula with this. And this is where a good student becomes an amazing student, because if you remember the quadratic formula, you're a great student. Negative b plus or minus, and I always write it because the square root is never the right size unless I do it last, all over 2a. Okay, for us, that's going to be 2 plus or minus 4 minus 4 times 1 times 1/2 all over 2. So we're going to get 2 minus the square root of 2 over 2 and 2 plus the square root of 2 over 2. So one of these is going to be the value that we want. We can simplify this. Feels like we're getting close now. To 1 minus, what's happening? 1 minus root 2 over 2 and 1 plus root 2 over 2. Root 2 over 2 is something you should know from trig a lot. It's about 0.7. So this would be about 0.3 for our x value. This will be about 1.7 for our x value. So let's look at the parabola. This has an x value of 1. So an x value of 1.7 would be up here. You'd have to look this way. So I think it's going to be the other one. I think we're going to have 1 minus root 2 over 2 as our x value. And since y equals x squared, we'll just FOIL this. We get 1 minus 2 root 2 over 2, so of course that'll cancel, plus 2 over 4. So we get 1 minus root 2 plus a half. So we'll say 3 halves minus root 2 for our y value. And our x value is what? 1 minus root 2 over 2. So if I want to put that in some kind of a decimal, this is like 1.5 minus 1.4. I want to say it's 414, because it has some kind of a, I remember it's repeating digits like that. And this over here is a 1 minus 0.707. So just to keep it generally simple, I'm going to call it 0.3 and about 0.1. Just to keep it simple. You need to find the exact actual digits. But that's pretty close. And I think on our picture that makes sense to say this is at about 0.3, 0.1. This 0.3 squared is 0.09. So yeah, this is pretty close to being on the parabola. And the exact decimal will be the correct answer. But that's how you find it. So when you're reading a problem like this and you say, hey, it's on a parabola, well, just remember, you don't have to use the negative 100. You can do this. So if I multiply by 100, then you would get 30 meters and 10 meters for your x and y value. But we've taken a lot of the trouble out that way. Then we find the slope. Make sure that you remember the derivative and the slope are the same, so you can use the derivative in comparison. And then replace your y value with the x version of your y value so that you can do some solving. Most importantly, keep the quadratic formula on hand, because you will need it even on a calculus test. I promise you that.